Hello students. Today I thought of discussing a certain type of questions actually we get in our A-levels. These questions will appear here. These questions comes with a percentage value. See now, length of a certain string. Let's say in the wave questions, stretch string, length of the string is increased by 21%. And tension is increased by 10% or something like that. Find the new fundamental frequency. Likewise, that kind of questions. But voltage is increased by 10%, and what's the increment of current? What's the increment of power, or something like that. So, applying percentage change is key here. Percentage change, percentage decrease, something or something like that. So, that type of ability to simplification and all that is a must. These questions are the difficult questions. Say now, you know theories, you apply the values, that's how you get the answer, it's okay. But these questions, when doing these type of questions, you need to apply your maths knowledge. Even the students who are doing maths find these type of questions are quite a bit difficult. I have noticed it. So I'm giving you a couple of sample questions for sure. Try those questions as well. And remember what I'm saying, at least there will be 5 to 6 these type of questions in your paper, the normal A-level paper. So practice these type of questions daily, weekly practice the questions when you are doing questions. These are, if you have this skill, just like the ability to apply ratio methods, this skill, percentage change, percentage application methods, you can do the difficult questions. So people say there are difficult questions, 10 to 15 difficult questions. So you can try these questions. If you want to get more than 40 out of 50 or close to 40 out of 50, you have to do difficult questions. Remember that. The questions others find it really hard. So these type of questions is one of them. If you practice these type of questions, you'll get higher marks for sure. So let's jump into the very first question now. I hope you have tried the question now. You can see the question, of course. This question they're asking, just read it. In order to increase the frequency of the transverse oscillation of stretched wire by 50%, the tension must be increased by, right? So the tension of in order to increase the frequency by 50%. If the frequency is F, this has to be increased by 50%. So applying this percentage value is the key thing here. It's a math thing, remember that. Right. So when F is increased by 50%, what's the value of F now? That you should know. F is increased by, so 50% mean, remember it's like this, 50 or, so this is actually for the students who find this is difficult actually. So if you are a good student, you can, if you can easily do this question, that's okay, that's fine. So this is actually for the students who are finding these questions a bit hard and all that, right? So I'm going with the basics. So if you know the basics, yes, skip the video, go to the answer and see whether your answer is correct, then you are good to go. So 50% is this. This is 50%. So when you take the fraction of 50% is this. So 50% of F means, you can see it's 0.5 F, right? So the frequency is increased by 0.5 F. So the final frequency will be 0.5 plus the original value F. So the final value, it will be 1.5 F. Right. So increasing values with the percentage is bit, it's not difficult, you have to practice this, 1.5 F. So the new frequency will be 1.5 F. Now we need physics. The physics equation we know, right? What's the physics equation for frequency? F equals fundamental frequency. Let's apply 1 over 2L root T over M. You should know this equation for sure, right? If you do not know this equation, you cannot do this question, right? That is physics anyway, right? So F proportional to, I'm taking it like this. Now we know root T, right? So initially F proportional to root T. Now we have 1.5 F proportional to root, let's say T dash. let's look at the question again. What are they asking from us? Stretched by 50%. The tension must be increased by the percentage increment of the tension. So anyway, we have to find the tension first. Let's find the tension first, and then right, what we have to do is first one and second one, let's divide these two. So we get 1 over 1.5 equals full root T over T dash. For further simplification, actually we need to take the square root out. I mean, we have to make it square. So I get 1 over 15 squared 2.25, right? 15 squared 225, so equals T over T dash. So moving into the further simplification, now you can see here T dash equals 2.25 T. So what's the increment here now? See, it was earlier T, now it's 2.25 T. So that's mean 1.25 T is the increment. Initial value T, final value is 2.25, so the 1 plus 2, 1.25, 2.25 is the increment. So they are asking us the percentage change in tension divided by original tension. So the change is 1.25 T, original is T, that multiplied by 100 we get 50%. That we get percentage, right? Okay, so TT cancel up, so we are getting 125%. That's the percentage change. So students, now even if you find it difficult to do this type of questions, if you find this is hard, that means the simplification part actually you are not good with. So let's move into the other question. I'll explain furthermore, a little bit furthermore in that question as well. Let's move to the other. This is quite a bit easy question. Let's read the question now. The frequency of B 3% greater than that of A. The frequency of C is 2% less than that of A. When B and C are vibrated together, the beat frequency obtained percentage the frequency of A. So let's say frequency of A is FA, right? Let's read the question. Frequency of B is 3% greater than that of A. 3% greater. B, FB, right? 3% greater. And the third one, FC, is 2% less than that of A. Plus, so the difference between them is 8. That's what they're saying. So if B is greater, FC is lesser, obviously. 3%. So just like that earlier we have taken 3%. Is this 3? This is the fraction of 3%. So this we have to multiply it by FA. See, so what are we getting now here? 0.03 FA. So the final value will be, so increase, this is the increment, 3% greater than FA. So this is the increment from FA. So the final value will be FA plus 0.03 FA. So it's 1.03 FA. This is FA. Right? So in the very same method, let's try for FC. So they are telling it's 2%. 2%, this is how we write the fraction of 2%. 2 divided by 100. This is 2%. Right? That we have to multiply by FA. So we are getting 0.02 FA. Right? That we need to subtract from subtract. So FA minus 0.02 FA. So from that we are getting 0.98 FA. Right? So now let's apply the normal equation of beat frequency. Beat frequency. Right. FB, that's a greater one. 1.03 FA minus 0.98 FA is equal to 8. So what's the difference? 0.05, right? FA equals 8. So FA equals 8 divided by 0.05. This is how I simplify it. So I multiply this by 2, I multiply this by 2. So it's 16 divided by 0.1. So 0.1, it's easy. I can multiply it by 10 and multiply it by 10. So 160 over 160. This is the easiest method to simplify this type of questions. So 160, that is the answer. So if you could follow through this, the method, if you could, let's say you couldn't do the question, but you follow through this and you learn something. Take that one to the next question. Friends, now we are in our third question. So this previous two questions actually we did from waves. So you might think these questions are only from waves and all. So here I have picked a question from mechanics. Right, let's read the question now. The diameter of a flywheel increased by 1%, and they're asking the corresponding percentage increase. Remember the word percentage increment of its moment of inertia about an axis going through its center. So percentage increment. It's not I, they're asking delta I. So percentage, this is what you need to find, right? So before getting the answer, you should know the question. So this is the question. Delta I, find delta I over delta I into 100. Right. Diameter is increased by 1%. What's the equation for I? Is mr squared, right? It could be half mr squared. It could be some other value, but still I proportional to r squared. So I'm gonna apply this to get the answer. So our answer, first one, I proportional to original r squared value. If diameter d is increased by 1%, d by 2 will be increased by 1%, right? I should do that. That's a question. That's the first question that should come into your head. Let's say if this is 100 diameter, so it's increased by 1%, that means it's 101. Right? Diameter was, sorry, the radius was 50. Now what's the radius? It's not 51, right? It should be 50.5, right? So 0.5 divided by 50 into 101 to 1%. Percentage change in radius is 1%. So that's correct. So even the diameter is increased by 1%, the radius also will be increased by 1%. So if you know this, now you know this, right? When you are practicing questions then again, right? Like, you know this, right? So just apply that. So that means our radius is increased by 1%. How do you increase it by 1%? 1 divided by 100 is the fraction. So 0.01 r. That's the increment. So the original value, the final value will be this one plus r, 1.01 r. Right? So the new I will be proportional to 1.01 r square. So what will be the final value? Let's see. It's I is I dash. Okay, I dash. Let's divide these two. Right? First one divided by second. So what are we getting? I dash over I equals 1.01 square divided by 1. So we get I dash equals 1.01 square. Right. You have to, yes, take this out. So it's 1 plus 0.2. Yeah, 1 square plus 0.2. Yeah, something else. So normally when we do these type of questions, actually we can only take these two values. So it's 1.02, right? I dash equals I. It's actually a method we use for simplification. It's like this. Let's do the simplification now. 1.01 square. So we can simplify it like this: a plus b squared method. So it's 1 plus 0.01, right? Square. Here we can take it as a squared 2ab plus b squared. So we are applying the very same method. So I get 1 squared plus this one into 2. So 0.02 plus 0.01 squared. That means 0.0001. So the final answer will be 1.0201, right? So this is actually quite a bit away, so we can neglect this 01 value, quite a smaller value. So we can only take it as 1.02. So when you are simplifying these type of questions, so if you get something like 1.02, let's say, square, you can easily take 1 plus this value into 2, 0.04. It's our answer, 1.04. This method can be applied for these type of smaller values. Remember that. You have to practice these type of things. Remember that. So when automatically it will come out from you. So practice these type of questions. So this is the increment, 1.02. So let's move into the question now. 1. Okay. 1.02 I is the increment. Is I dash, right? What's the increment? 0.02 I is the increment. Is delta, right? So delta I over I. That means 0.02 divided by I. Here I into 100. You can see 2%. That's our answer. Or you can apply this value. So when you apply this value, you get 2.01%, right? So answer is not there. That's 2% is our answer, right? I hope you have learned something. Let's move to our next question. Alright, students. I hope you have tried the question, you have read the question. People who can do the question, just do the question, right? So those who cannot do the question, they are telling the relative humidity of a room is 50%. Now few people occupy the room. Now the relative humidity has increased up to 70%, right? And they are asking us the increment of the change in water vapor content in the room, right? So what's 50% relative humidity is amount of water vapor present now, delta N, the same, right? Divided by amount of water vapor when it is saturated, MS. One thing we know, the temperature is not changed. Remember that. So multiplied by 100, so we are getting 50. So let's write it here again. 50 equals M over MS into 100, our first equation. In the second equation, they are telling the temperature of the room is not increasing. That means the MS value here, the saturated mass is not increasing. So 70% still there. Mass M, let's say delta M, so that's the increment. That divided by MS and multiplied by 100, we get 70%. So that's our second answer. Alright. So because of this, the increment is here. So what we need to find this delta M value. So what we can do is actually we can divide these two. So MS will cancel off and we might be able to find delta M. So let's divide first equation by the second equation. First one divided by the second. So 50 over 70, MS cancel off. So M divided by M plus delta M, that's the only remaining one, right? So it's this. Right, so finding delta m is the thing here. So let's do the cross multiplication. 50m plus 50 delta m equals 70m. So I get 50 delta m equals 20m. So delta m equals 2 over 5m. That's the amount. That's delta m, right? So delta m is this. So they are asking the percentage increment, right? Delta m divided by original value mass n. So that into 100. So you get delta m as 2 over 5m divided by m into 100, right? M and m cancel out. 2 over 5 into 100. So 200 divided by 5, it's 40%. You missed that part. So I'll write it here again. So delta m to divide by m into 100. So delta m we got, it's 2 over 5m, right? Here you can see it. 2 over 5m divided by m into 100. So m and m cancel off. 2 over 5 into 100, that's 200 over 5, that's 40. It's 80, right? 200 over 5, that's 40. Yeah, 40%. That's our answer, right? Percentage increment. I hope you understood, you got a certain idea of this type of questions. But remember, students, within these 4 questions, actually you will not get the whole idea. You have to practice these type of questions. So from your papers and all that, you have to find these type of questions and try these questions, whether you see whether you can do these type of questions. So if you are able to do these questions, that means you know how to do these percentage questions and all. But if you are not able to do these questions, remember that there will be this is actually a past paper questions. So try questions from past papers as well. So you should be able to do these type of questions, because difficult type of questions will come out from these type of methods, right? I hope you learned something. Yeah, right, great.